discussion.
So you know how when you define T, data type T,
Mhm.
is that, I thought it was that was like in general, they use the as general,
Mhm.
like instead of putting string, like they just put it, but we actually put T,
Right.
right? I thought it was just like a place. like,
Yeah.
Or whatever you want.
Yeah, maybe a concept that you're not familiar with, and it was new to me when I first got exposed to it. But what it does is, like, say, for example, you're creating some code and you don't know if you're going to, the user is going to have it all strings or integers or anything else. This generic, it just gives you a code that you don't have to change at all. And so when you actually construct it, you have a constructor in it and it says, this is what it is. That's kind of the magic that's associated with it.
So if you put T, it has to be all of one data type.
Yeah.
Right? Okay.
Yeah,
You can't just add string and integer.
right. So we will have later, when we talk about dictionaries, we'll have two generics like T and V.
T comma V or.
Yeah,
Right.
right. And so that T is always going to be the same thing through that instance, and the other one will be always the same thing. So maybe strings and integers or something
Did
like
you say
that.
V?
Yeah,
It could be any letter.
yeah, it could be.
Oh,
Like, for dictionaries, we'll talk about key and value, so it'll be
Yeah.
K and V
right.
in that situation. But
So let's say, how we're using T, it has to be T, right? We can't just put like a.
you could,
I could,
yeah, just as long as you use it consistently.
but in general, we use T.
Yeah, that's why the convention we're going to use, at least if following from our what we have from our textbook. Okay. All right, I'll go ahead and open us up in prayer, and then I'll go ahead and give you a sense of what we're going to be covering today. Dear Heavenly Father, Lord, thank you for the chance to be working with each of the students in this course. I pray that you would help them to master the material that we're discussing, and that each of the topics will be things that they will find useful in their future profession. Also, I pray that you would help them in their spiritual formation, Lord. I pray that as they get a chance to be studying scripture, all of that is going to be treasures in their heart that they'll be able to draw upon when they're thinking about theological concepts they want to be applying, and give them interesting and creative ways for faith integration. In Jesus' precious name we pray. Amen. Okay, so we're just continuing our journey here. And so last Thursday, you got a chance to get a little bit of an idea what it'll be like for us to be doing some implementation. I walked through a generic example and how to use an interface, do an implementation with an interface. We were just before we started, we're talking about these generics, talking about that T, that's going to be the convention we'll use until we get into dictionaries. And now we're going to be talking about well, first of all, we have an interlude on exceptions, and then we'll get into a implementation of bags with a linked approach. Hello. So let's just talk a little bit about exceptions, and then I'll give a little bit of overview of doing an implementation with a linked approach, and then we'll do our video notes to kind of complement what we've got from what we're talking about here. So an exception is an unusual circumstance or event that usually occurs during the execution of a method, thereby interrupting program execution. Some exceptions indicates mistakes in your code. By correcting those mistakes, you avoid the exception and you no longer have to worry about them. In fact, your final code gives no indication that an exception could occur. Further, if your code is entirely correct, an exception will not occur. On the other hand, a programmer can intentionally cause an exception to occur during certain conditions. And so this is where, do we want it to just fail, or we just want to be able to handle that type of a condition? So this is where we get into that whole idea handling an exception, we can either postpone handling it, so we can throw it to something. So, hey, we saw this. Okay, you're going to go to another part of the code, and maybe you can actually figure it out. So you can handle it now with something called a try-catch block, and or you could have multiple catch blocks that are there. And then we have throwing an exception. So these are all the things that are built in within Java. So so a method creates an exception object. We say throw an exception, and it's a signal to the program and something unexpected has happened, and you need to figure out what to do. So handling the exception, detect and react. And so I remember when I was writing C code in the past or something like that, and it either works or it doesn't work. And if it doesn't work, then you got to find out what that area is, recompile it and resubmit it. Well, with programs like Java, there can actually be a middle ground. It says like, okay, you just entered this. Is that what you really meant? And you can say have a second, maybe or a third chance. And so these are examples of the things that are built in Java: the class not found, file not found, IO exception, no such method, and write abort exceptions. And so these are the things that we're trying to consider maybe what we're going to be doing. So then we have the runtime exceptions. So this is a listing of the checked exceptions, and then we get into the runtime. And so by having a variety of these exceptions, it can help you with troubleshooting your code. And maybe some of these are something that you can handle. And so that's what's laid out here. We'll have plenty of examples in our code that we'll be going through. And so we have an object, and so an object is in terms of exceptions, it can be throwable, and so it's either an exception or it's an error. And so this are some of the distinctions that could be dealt with. So the exceptions, these are things that maybe we can revise things, or we'll have like an example later in the semester. We'll talk about if we wanted to create an implementation of doing taking the square root of a negative number, dealing with imaginary numbers. And so with the exception, you handle it, and then you take the absolute value and keep in mind that it's we're dealing with a negative number. Then you calculate it through what you know will work, and then you at the very end you stick in a little I there to deal with imaginary numbers. That might be an example of how you can handle it. So you can handle exception, you can postpone it, you can throw it to somewhere else, and perhaps it can handle it there. Maybe it goes down to a subroutine and says, uh-oh, it goes back up. And if it's able to resolve it, then it could be sending it back down to that subroutine. You can handle it now. You can have a try, and then you could catch it. So that's one possible way of resolving this. You could have multiple catch blocks. And so that would be things that you could be doing as well. Finally, you could throw an exception. All of those are within the realm of possibilities of what can actually take place. So there is a video note on that. I think maybe I'll just skip over that. I'll just get into an overview of thinking about how we do a bag. So remember what they did. Well, the first thing we introduced this ADT, what is a bag? And so we're trying to be focused in just like a grocery bag when you're going out of the store. And so you don't know, there's no like object number one, object number two. There's just a simple things, and it actually had more capabilities than just is it in the bag? What's the number of elements? There's a couple other things that are captured as well. But we don't have things that are going to be exposed later when we talk about like a list or something like that. Maybe part of our implementation that's not exposed to the user might involve that, but that's not something that is available externally. So we have this idea of an iterator. We're going to get into more possible things here, but an iterator is an object that traverses a collection of data. So it's easier for us to think the first one, the second one, the third one. So it's how we can go through that collection of data. So we have an abstract data type, and then we make a data structure out of that. And then we want to be interrogating what are the elements that are associated with that. During iteration, each data item is considered once. It's possible to modify the item as is accessed. And it should implement as a distinct class that inherits, interacts with the abstract data type. So we're going to see that there's pros and cons for these various things that we can be doing in our implementation. Maybe I'll just go back to this one chart that I said that is everything in one chart for just a minute. So we're still focusing on bags. We talked about the implementation that we're going to be doing is we're going to be implementing a bag. We're going to have the interface, which this is the things that we're going to be exposing to the user in the application. So they could write it, we could write it. But within this implementation now, we can be thinking about doing an array implementation. We talked about that last week. Now we're going to be talking about a linked implementation. There's going to be some more choices as we work our way down, but that's the next thing that we're going to be focusing on here. And so that's where we are today. So going back to where I was. So we have a choice. Are we going to do a linked implementation or an array implementation? So what's the pros and cons? Well, here's some of the negatives about an array. An array has a fixed size. And so we have to be careful. Is it full or not? It may become full. Alternatively, it can have wasted space, and resizing is possible, but requires overhead of time. So analogy is like you have a classroom here. We could have more students in this class. So there's more capability. So we could argue we could have gone to a classroom that was smaller. So maybe we're not using the full potential of this class. But on the flip side, we do have a maximum capacity in this class that we've book kept for. So that's maybe something that you can be thinking about. So maybe you have a chain or a necklace, and you can see how those little things hook together one to another. That's what it is that we're doing, is we're forming a chain. And so with each element, it's going to show that there's a relationship between that element, there's the contents of that element, and also points to what the next one is. So those could be different memory locations. They don't have to be adjacent memory locations. And so this just gives you a little bit of a sense of the different characteristics that we have with a chain. So we'll see this in the video notes, but before we get into code, we have first of all, having a narrative. This is what will be walked through here in a narrative. Then we start to get into some pseudocode of what that might look like. And finally, getting a chance to think about the implementation. So when we're dealing with a linked implementation, we're going to have a private class. So we talked about with a UML notation that the things that are made available to the user are public. Things that are not made available are private. So this talks about our implementation. And so going once again to this little chart here, how we implement it is our choice. What's exposed to the user is something that's going to be different. And so that's something that's at our discretion that we can be thinking about. So this is where we start to get into the implementation that will be producing this private class. And so this is a noun. We're creating a node. And for each node, it has certain characteristics. Since it's a class, we have to do a constructor. So there's two forms of constructors that are there. Then we get into the methods. Well, this is an implementation of that class. And we'll be showing examples of this when we get in our Thursday sessions, but this is now just looking at an implementation. So we start out with our constructor. So this is a part of the code where we do how we're going to write it out, and now we're doing it with a linked implementation. We have a private class node. This is something that has to be there. And then we have some more methods we have to implement that we'll be getting to in a little while here. So the video note will give a better way of how we look at this, but these are some things here in the lecture notes that you can refer to. So then we have our core methods. So when we do the implementations, remember we cherry picked a handful that we're going to start with, and others we just have code stubs. And so this would be an example. Well, let's look at the method add. So as you've seen, although it might appear that an empty bag is a special case, when adding a new entry to a bag, it really is not. So we're now just looking at how this would work here for the method add. Then we have toArray. We did that for the array implementation. And so this is how we're making available to the user all the things that are in that bag listed as in a Java array. So that's possible. Then we have the main method. This is the third piece that has to be in an implementation. And so then we just see some examples of populating some contents that we're going to be putting in that bag. And we notice here that this A bag is going to be made with a link bag 1. And link bag 1 is see if I can get back to the beginning here. So this is the link bag that we're going to be implementing here. And that's what we have left. We have some of this other complicated stuff where we have these unchecked warnings. And so just that when we're trying to create a variable with this generic type, where we're trying to acknowledge we know what we're doing. For the sake of this class, we can just take this verbatim. You can just use that. This is maybe a concept that may be new to you as we're going through this material. So then we have a test program. And so this is a word I could use as a driver. We don't have a specific application. So each one of you have come up with an idea of what you want to be doing with your code. And so this is just giving how that would work. And then we see the output, and we'll see this in more detail when we look at the video notes. We then have some other methods. We have the get frequency of, and we have the implementation for that. The method contains. We'll get an explanation of that in the video note. And as we get into some of these things, when you do the implementation, there may be various cases that you have to be looking at how to program. And so we will see this in our second video note, that it'll walk us through how that would work. So you can have like a simple case. So you're the first person. So you're the first chair in the room, if you're using that analogy. And for every other case, when you're not. And so this would be we're parsing out the code in terms of doing the implementation based on that information. We have the method for remove. We have that. This is a more involved version of the class node, and so we're adding some more details. And so this is something that we'll talk about in the video notes as well. So I just wanted to do a quick run through the PowerPoint before we go over to the video notes. And so just like the array implementation has its pros and cons, the pros for using a chain, a bag can grow and shrink in size as necessary. So you don't have to constantly checking its how full it is. Remove and recycle nodes that are no longer needed. So it takes care of that. Once you don't have a pointer to it, it goes away by the Java garbage collector. Adding new entries to an end of array or beginning of a chain, both are relatively simple. And it's similar for removal, just like talking about for addition. The cons: removing a specific entry requires searching of an array or a chain. The chain requires more memory than an array of the same length. And so there are some things on both sides of the fence that are worth considering when we look at how we're going to be doing an implementation. And so I've had students go both ways. Some people say that, hey, I like the array. It's easier to conceptually and understand. But the others say that once you get past the learning curve for a linked implementation, that makes a lot more sense, and I'd rather do it that way. And so I'll leave it up to you in terms of what you might want to be doing for an implementation. Okay. So, like I said, we already talked about the array implementations. We did an overview of the exceptions. You can review that video note when you would like. And let's go ahead and get into this linked implementation, and we'll actually have 3 video notes to give us some. Let me see if I got if it auto detected the right audio. So give me a second. Okay, good. See if I can finesse the volume. I think I'll just have to do it this way.
This lecture presents the concept of linked data. Let's begin by looking at someone who needs to store some items. Here we have a young business executive that is moving into a new office. He needs to pack up his prized realistic stuffed animal collection for transportation. The moving company has a set of trunks that he can use to pack up his toys. Each trunk has a reference number so it can be tracked. Okay. So we're talking about an abstract data type. We were talking about this generics. And so we could say, how are we going to categorize these? Are they going to be a string? So we're calling it a rhinoceros, a polar bear, a turtle, whatever. Maybe something else, but we have some kind of similarity in the way that we're going to be designating those, right? So that's what we're going to be putting in this chest. But what you're going to see in a minute, there's also going to take a link to a next one. And if there's no link, then it's left null. And so that's how we can tell if there's a next element. And enough space for one toy and the reference number of another trunk. Because our executive is so busy trading stocks and making important decisions, he only has time to remember the reference number of one trunk. Each time he asks the moving company for a trunk, you notice how these aren't sequential. So it could be bouncing around memory or however Java, whatever it wants to be putting that in. And so that's just another characteristic we see. He doesn't know what number will be on it. Since he can only remember one number at a time, he places the number he knows in the new trunk along with it. So you only can remember one number at a time. Once again, we're bounding the implementation complexity
of what it is. So this is a linked implementation. It can only remember one thing. It has a content, and only can remember, have a pointer to the next one.
The toy. Then he works at remembering the number of the newest trunk. As he receives each new trunk, he repeats these steps of placing the toy and the number of the last trunk into the newest trunk, and he only remembers the number of the newest trunk. Using this method, he has formed a chain with the trunks. He knows where the first trunk is located because he remembers that number. To get to the second trunk, he looks at the first trunk to find the second trunk's number. He can use the same technique to find all of the other trunks. He knows
So they're calling this the first one. This is the last one in, maybe giving you a sense of how the orientation is. And so every one of these has a relationship to a next one except for this last one. And so this is how you can tell that you're at the end of this linked chain, because this is a null, okay?
he's reached the end of the chain when he gets to a trunk that does not have a reference to another trunk. The next trunk compartment is empty or null. We can use the same idea to hold a collection of data in our bag. We represent the trunk using an object called a node. Nodes are objects that are linked together to form a data structure. Each node has two fields. One references the data item stored in the collection. The second data field holds a reference to the next node in the chain. When there is not a node following the current node, the next data field is null. We typically represent that with a slash or a dot in our diagrams. To access the nodes linked into a chain, we only need to hold a reference to the first node. This reference is often called the head or first node of the chain. Sometimes, to reduce clutter in our diagrams, we show the item referenced by the node's data field as if it was stored in the node inside the data field itself. This does not imply the object is in the node. The node still contains only a reference to the object. Let's look at an algorithm for building a linked chain by adding new nodes at the front or head of the chain.
So you see, this is what they do. They always introduce a concept first verbally, giving you some of interactive way of considering that. Then they put it into a narrative, and then pseudocode, then finally the code. And we're seeing this process now for how we would do things for a linked implementation.
We start with a variable that holds a reference to the first node in the chain. This should be null when we begin, since there are no nodes in our chain. When asked to store an item, we create a new node, store a reference to the item in the data field of the node, and then store a reference to the node just created in the variable head or first node, whichever we decide to call it. The steps to store additional items in the chain are very similar. As long as we are asked to store items, we create a new node for each item, store a reference to the data item, and then, since there is already at least one node in our chain, we copy the reference from our variable head into the next data field of our new node. Then we store a reference to this new node in the variable head. These are the same steps that are then repeated for each additional item we want to store.
So creating a node, remember that's going to be a private class. Okay, so you're going to have a subclass. We haven't gotten into that, so there's different ways of how you're going to be doing it, but this is the only place that's going to be using, so it's going to be a subclass. You want to store reference to item, copy a reference, store the reference to a new node in the head. So we're trying to see what exactly do we have to code and how much.
How would we define a node? We can make our node generic so it is able to store whatever type of data we need. We begin with the data fields. Data is a reference to an object of the generic type T, and next is a reference to the next node in the chain. We can create two constructors. The first takes a reference to the data to be stored in the node and the next node in the chain, and then uses these to initialize our data fields. The second constructor only takes a reference to the data item to be stored and initializes the reference to the next node to null.
So we have two possible ways that we can be calling upon this. One that we only are giving the data portion. and one that we have that there's a next node. So just basically nothing, you just initialize something, or in another case where there's actually a next node.
Don't need a default constructor, since without data to store in the node, we don't even need to create the node. Last, we could implement simple accessor and mutator methods, or setters and getters, for the two data fields.
So that's a term that you'll hear. So to set, you're either adding or subtracting. To get, you're not actually changing your data structure contents, you're just querying what that contents is. So set and get.
An alternative way to implement the node class is to implement it as an inner class of another class. An inner class is a class that is defined entirely inside another class, as can be seen here, where the class node is defined inside the class linked bag. This is usually only done if the class is a special purpose class that is only going to be needed by the class within which it is defined. Because no other class needs to access an inner class, they should be declared private. An outer class is the class that encompasses the inner class. In this case, it is the class linked bag. An outer class can directly access the data fields of an inner class, even if both the inner class and data fields have been declared private. So often, inner classes will not have accessor or mutator methods. Inner classes can also share the assignment of a type to the generic type T of the outer class. So the class definition for a generic type does not have to have a T in angle brackets in the header of its inner class definition, but it can still use the generic type. When implementing the linked bag class in the next lectures, we'll not be implementing the class node as an inner class. Instead, we'll use the node class as we originally defined it here.
Okay, so we have a choice. We can make it an inner class or not. We'll be thinking about that, but let's just go ahead and do two other portions of this. First, now we had to get an idea of this inner class, creating a node, get a general sense of what we're trying to accomplish here. I'm going to mute it while it plays that introductory music, and then I'll put the sound back on in just a second here.
First part of an implementation of the ADT bag that uses a linked chain to store the data in the bag. We'll call this class the linked bag class. We'll follow many of the same steps that we.
So you can see that, well, first of all, a general comment, putting in documentation comments in your programming is really important, not only for you, but eventually, say after you graduate, you're going to have to be working with other folks, and they need to figure out what you did. Even like the authors in the textbook, I wish they had put more comments in. It's in some ways, it takes a little, it took me a little while to work through it. But you'll see that the naming convention,
Implementing the.
you're actually, by the way you're naming it, you're almost producing comments. So they're going to call it link bag, array bag. So we saw array bag already.
Class array bag by deciding on data fields, implementing our constructor to initialize the data fields.
So we have the interface. We've already spoken about this, so they're not going to really talk about that in much detail. But strangely enough, when we talk about stacks and queues after this, there's not as many methods. There's actually more capability within the simple bag in terms of what's made available to the user than we'll have in our next two abstract data types.
Implementing our core functions such as the add and toArray methods. At this point, the implementation of the linked bag could be tested, and then we can implement additional methods. This linked bag will use a node of generic type to store the items in our bag. Here is the implementation we developed in our previous.
So sometimes they'll do inner classes, sometimes they won't. Right now, they just have a separate class that's capturing this node. Remember the way the last video was at the chest that you put the contents, whatever it is, an animal. And if it's not the last item that's going to be a pointer to the next one in the chain. So just like you have one chain link fits into another, it only knows about that next chain link.
Lecture. We're not going to define the node class as an inner class. We will keep it as its own class. The data in our linked bag implementation is stored in a linked chain. To manage our linked chain, we only need to store a reference to the head or first node of the chain. So we declare a private data field of a generic node type called first node. We should also track the number of entries stored in the bag. In our array bag implementation, we were required to store the number of entries so we could determine which array elements had data from our bag and which array elements were beyond the entries in the bag. This situation arose because we had to declare an array large enough to hold all of the items we might possibly need to store in the bag. Number of entries let us know where the last entry was stored. In a linked chain, we only create nodes when we need to store an item in the bag. Therefore, every node in the chain is used to store data. An alternate implementation of our class could decide not to store the number of entries, but instead, every time we wanted to know how many items were in our bag, we could iterate through the chain and count the nodes. This would work, but as the bag grows to hold more and more items, this would take longer and longer. It is more efficient to store the number of entries currently in the bag and update the number every time we do an add or remove.
So we're going to get into this next when we talk about complexity, big O notation, how long does it take to do different operations? That's going to be one of the things that's going to help us decide one implementation versus another. So a linked implementation doesn't have to have a number of entries, but it's going to make a big difference in terms of performance when we have it. If for example, I didn't have this nice way of having this naming convention, a linked bag versus array bag, you might, after a while, pick up the different types of variables, the way the constructors are set up, to know what type of implementation they're actually using. I still would recommend that you use this kind of naming convention, but that's just another point I wanted to make a thought for you to be looking at. We now have looked at the array, and now we're looking at the linked implementation.
Our linked bag needs only a single constructor. When we implemented the array bag, we gave the client the option of creating an empty bag with a default capacity or an empty bag with a capacity specified by the client. Since the linked bag has a capacity limited only by the memory in the computer, we can have a single constructor that just creates the empty bag. The constructor must initialize first node to null since there are no nodes in the chain when the bag is empty. And it must initialize the number of entries to 0 since there are no items in the bag at this point.
So this is a separate class. Okay, it's public. And so that's just another distinction I'd make. And so they talked about this constructor that we would have.
Now that our bag is initialized and empty, we can begin to add items to it. Let's step through how our add algorithm is going to work. When our linked bag is first created, it is empty. First node is null and number of entries is 0. Our add method is passed an item to add to the bag, in this case, giraffe. We create a node and a reference to the item in the node. Then we copy the reference in first node to the next field in this node. We call the setNextNode method of the node to set the value of the next data field.
We'll get back to this. I think this is an example of a private method. Yeah, but we're still, yeah, that we're doing the implementation, so we're using the node, but I think we'll come back to that.
For the first node created in the chain, this seems redundant since the first node has the value null and the next data field of the new node has the value null. But this step becomes more important once the chain has one or more nodes in it. The reference to the new node is copied to first node, so the first node now points to the newly created node. Notice that here we use an assignment statement to set what first node references. This is because we are assigning the member variable first node itself to point to the node. Earlier, we wanted to assign a data field of the object new node to reference or point to a node. Since we are assigning a data field of the object, we use the setNextNode method. Once we have set the references correctly, we can increment the number of entries in the bag. When the method ends, the local variable new node goes away and we are left with only our chain representing the bag. We can repeat these steps for the next item that is added to the bag. We create a new node for the item. We call setNextNode to reference the next node. We copy new node's value to first node, and we increment the number of entries, and then return true to indicate the add was successful. And we repeat these steps with each call to add. The two statements that assign references must be done in the correct order, or you may lose all but one of the items in your bag. Let's see how this could happen. Here we've switched the two statements that could be a problem, and we have a chain that already has two items in it. When we go to add another item, in this example, turtle, let's see what happens. We create our new node correctly and store a reference to turtle in it. Then we set first node to reference the new node we just created. Now, when we go to set the next data field of the new node, it is set to reference or point to itself, since that is what first node points to. If number of entries is then incremented, it reflects the fact that we should have 3 items stored in our bag, but because of the error, we can only access 1 item. The items in the remaining nodes are lost. This is a common error when working with linked chains. Let's return to our original correct implementation here. If you remember from our node class implementation, we had 2 constructors. One is used here and has a single parameter that is the data to be stored. The second constructor had 2 parameters, the item to be stored and a node for the next data field to reference. We can use the second constructor here to help us avoid the problem of accidentally switching statements. Since when we add an item to our bag, we always add the node that contains it to the front of the chain. We can set it when it is constructed to point to the node that is currently the first node in the chain. We can optimize these statements further if desired by eliminating the local variable new node. Here we create the new node and correctly set its data fields in the constructor, and then immediately assign first node to point to the newly created node.
Yeah, this might be a good point just to stop for a second. So even this for first time might be kind of hard to follow, but then they've gone to next level and even beyond that, a 3rd level. I remember it's kind of embarrassing in one way, but I've got a twin brother when we both went to USC as I was a freshman. And so I was in this programming class and I asked for my brother for help. And so he helped me. And so I got an A on the assignment. It says, "This is tremendous. This is the best code I've ever seen." And I'm going, it's like my brother helped me with this, you know? And so that's what this is the kind of thing that he would have turned in. This is what the kind of thing, if I had done it all on my own, eventually I would have figured this out. Make something, especially if this is the beginning, make it something that you can follow. You can notice that there still is not a whole lot of documentation on each of these 3 implementations, which I think would be better if you had a little bit more. Which brings me to a point, and I got asked that, well, do we need the textbook? Do you need to buy the textbook? And I didn't really emphasize it on the first day. So please do make sure that you get the textbook. There's a lot of good information. It's like, maybe an analogy is like what we're doing in lecture and stuff like that. It's kind of like you're getting a chance to see it in black and white, maybe seeing a little bit of color, but by getting the whole textbook, you're going to get a chance to see it fully in color. And I want to make sure that you're able to do that. And they've also been kind enough to provide all of these resources that we use in this class, which I'm very grateful for. So that's just maybe a long-winded way for us to be thinking about this refined code that they're sharing here.
Each of these 3 implementations work the same. Now that we can add items to our bag, we need a method to tell us if they were added correctly. The toArray method can help us with this. It begins similar to the toArray method that we implemented in our array bag class. We create an array called result that has number of entries elements and is of the generic data type stored in the bag. Next, we take the items in the nodes of the linked chain that represents the bag and copy them into the array. Before we code the copying of the items, let's look at how we can accomplish this. First, we have the chain that represents the bag. The data field first node references the first node in the chain, and the data field number of entries holds the number of nodes in the chain. We have the array result that was just created and has the same number of elements as our chain has nodes. As we iterate through the chain and copy items from the chain to the array, we need two local variables to track our position, one for each data structure. The variable current node is going to reference the node in the chain that we are currently examining. When we
So this is an example where maybe if you start to just do the later video notes and you don't remember the earlier ones, you can see here, they didn't even talk about the suppress warning. And we talked about this kind of a construct. And so this is something that we covered last week, just to keep that in mind.
begin, we want this to point to the first node in the chain, so we initialize it to first node. Index is the index of the element in the array result, where we will place the item from the current node. When we begin, we want the first item to be placed in the first array element, so we initialize index to 0. We can now copy the item from the current node into the first array element. Then we move current node to point to the next node in the chain and increment index to reference the next element in the array. We can repeat this process for each item in the bag. When we copy the last item in the chain, current node is set to null since the next data field of the last node is null. Also, we know that we've processed all of the nodes since index matches number of entries. We can use these two facts as a test for when we should determine the while loop that processes the items in the bag should terminate. This is a statement to get the data from the current node and place it in the array element with index as a subscript. Then we set current node to reference or point to the next node in the chain. This statement is a common way to increment a variable used to iterate through a chain, similar to how ++ is used to increment an index into an array as we iterate through the array. Now that we've completed the add and the toArray methods, we are able to test the core methods of our linked bag class.
Okay, so we talked about first, what is a linked implementation? We talked about a linked class, a node class. Then in this video note, we talked about the key methods that we need to implement. And then finally, we'll finish up with this last video note, and this will complete the picture for a linked implementation. I'll just go on mute for a minute in the video, but so it doesn't boom for the very beginning. So.
Continues the implementation of the linked bag class. We begin by looking at the methods that remove items from the bag.
So we looked at the add, we looked at the toArray before. Now we're going to be exploring some of these other ones. We'll see some similarities between the remove and the add, and that will be the one that we'll look at here.
There are two methods in the bag interface that our client can use to remove items. The first remove removes a random item from the bag and returns a reference to it to the client. The second searches the bag for a specific item, and if the
Which one do you think would be faster? Just to remove whatever item we choose, or remove a specific item? Anybody have a guess?
This one.
Yeah, because if we're going to just do remove any item, I'll remove the ones that's easiest for me to remove, right? And if for remove a specific item, you have to find out which one it is, right? And so we have limited access to the contents, and so we have to iterate. There's that concept that we talked about, this iteration.
Item is found in the bag, it removes the item and returns true to the user. Otherwise, it returns false. When removing items from a linked chain, there are two cases we need to examine. Case one is when we must remove the first item from the linked chain. This is the simplest case, and so we will use it when we're asked to remove a random item. We must also remove the first item if we're asked to remove a specific item and it's the first item in the chain. The second case is when we're asked to remove a specific item and it's not the first item in the linked chain. This case has a slightly more involved implementation since
You might remember I very quickly went through the lecture notes and I talked about these two cases, but now this conception might help you to get your arms around the first element here. And then there's every other element here. So case one's going to be faster and other cases are going to take more time because we have to find it first.
we must search the linked chain and manage additional node references. One other important thing to remember when working with linked chains is that we want to return the item stored in the node, not the node. And when we're searching for an item, we want to compare the search target with the items stored in the nodes. Our client knows nothing of nodes since that is an implementation detail. The client is only concerned with using our bag interface implementation to store some data. The fact that we use nodes in the linked chain should not change how our client uses the bag. Let's see how we can safely remove the first item from a linked chain. Our implementation of the remove method begins by declaring a variable of type T that we can use to return the item we remove from the chain. The bag interface specifies that we can remove a random item from the bag. Our implementation will always remove and return the first item from the linked chain. Before trying to remove an item, we must check to see that the bag is not empty. We can compare the value in first node to null. If first node is null, it is not referencing a node, and so the bag must be empty. As an alternative, we could call the isEmpty method, which checks to see if number of items is 0. If the bag has one or more items, we get the item stored in the first node and save a reference to it in result. This saves the item so that when we remove the node, the item is not lost along with the node. Since the first node in the chain is no longer needed, we can have the data member first node reference what is currently the second node in the chain. We copy the reference in the next field of the first node in the list into the data member first node. There is now no variable that holds a reference to the node that used to be the first node in the chain. This node will then be deleted when Java's garbage collection runs. Our linked chain has one node less, and so our bag has one item less.
So we're kind of saying that it can be useful to have some kind of a cartoon that's helping you with this. Maybe when you're doing your implementation or your application program that uses the data structure that you've created, you might want to be thinking about that. Maybe it's going to be some modification of the sample code that you already have. That's fine. You do have a fair amount of the code for this bag that I shared with you. So if you wanted to do a array bag implementation for your first sub-project, you're going to have a heads up that you can be leveraging that. You're just going to have to take the driver and convert it to things that are relevant for your application. So those are just a couple comments there.
We can decrement number of entries to reflect that the item has been removed. Last, we can return result so the client knows what item was removed. Let's reset our bag and linked chain and see how we can use a remove method to help us remove a specific item from the bag. Here is pseudocode for a method to remove a specific item from the bag. As we step through this algorithm, it's important to keep in mind that nodes only exist to store items in our bag. Which node contains an item is not important. We first find the node that contains the item. If the item is not in the bag, this should fail and will not be able to remove the item. If the item is in the bag, there'll be a node N that holds it. We copy the entry stored in the first node into N. We do this since we already know how to remove the first node from the chain. Placing the entry in first node into N will keep that item in our bag once the first node in the chain has been deleted. The value that was in node N previously is not important and is to be removed anyway. Since the item that was originally in the first node is safe, we can remove the first node from the chain and either return true or false to indicate success or failure respectively. There are 3 actions that we perform in our algorithm to remove a specific item from the bag. First, we locate the node that contains the item. This is similar to the task we must perform when we check to see if our bag holds an item in the contains method. Our contains method returns a Boolean. Here, we must return a reference to the node so we can access that node again later. Since the 2 tasks are similar and only differ in what they return, we're going to create a private method called getReferencedTo.
So the way that they implement their code, you'll see they have a lot of private methods. And so when you look at the implementation, it can be fairly short. And then you realize, they're calling another method. And so with Eclipse, if you just hover on it, and if you click on it, you can actually go to that method a little bit later in the implementation. Or that's just another little tip that I can give you on that point.
That can be used by both the contains method and our remove algorithm. We have to replace the value stored in a node. Earlier, when we developed the node class, we had accessor and mutator methods for both of the node data fields. We can use the setData method of the node N for this task. To remove the first node, we can use the remove.
So once again, because we're thinking of a bag and the relationship between one item and another doesn't matter because it's not in an order, we can just arbitrarily, we find it. Okay, I'm just going to replace it with the first one. So I swap them and the first one's going to go away. So it's starting to look a little bit more like the first remove we just spoke about. So there's 1, 2, 3 things that we're doing. First, locate it. Then we're going to swap the first element with that one in there and make sure that each one links to the next one. We're going to be changing those links, and that's what we're finishing up with that point there.
Move method we just implemented. Let's first implement the private method getReferencedTo. Earlier, when we implemented the toArray method, we needed to create a variable that referenced the current node as we iterated through the linked chain. We again will be iterating through the linked chain as we search for the node that contains the target entry. So we declare the local variable current node and initialize it with the reference to the first node in the linked chain. We then iterate through the linked chain until either we find the item, thus setting was found to true, or we reach the end of the chain, which results in current node being set to null. If the bag was empty, the member variable first node would have been set to null. So current node would have been initialized to null and the loop would have been skipped. At each node, we compare the target entry to the data item stored in the node. If they're not equal, we increment current node to reference to the next node in the chain and repeat the comparison at that node. We continue incrementing current node and comparing until either we find the item and set was found to true or reach the end of the linked chain. If the item is found, current node references the node that holds the target entry. If the bag was empty or the item was not found in the bag, current node will be null. Now we have the tools we need to remove a specific item from the bag. When our method is called, we have the target entry that we're asked to remove from the bag. We will use the Boolean result to return to the client our success or failure in removing the requested entry. The first step in our algorithm is to locate the node N that contains the entry we want to remove. After our call to the private method getReferencedTo, our local variable node N will contain a reference to the first node in the linked chain that contains the entry, or null if the bag is empty or the entry is not in the bag. If the entry is in the bag, we replace the item in the node N with the item stored in first node. This is an important step. Since we're going to remove the first node shortly, we must ensure the data item in the node is preserved. The data in node N is going to be removed from the bag, so that node is a good place to store the first node's data. As mentioned earlier, when working with linked data, it is important to understand that nodes exist only to hold data. Which node an item is stored in is not important as long as it is in a node in the linked chain. Now that the data in the first node has been saved in another node in the linked chain, we can safely remove the first node from the chain. The remove method also decrements number of entries for us, so we do not need to explicitly do that in this method. Finally, we return result to indicate whether or not the remove was successful. The bag interface method contains is simple to implement in our linked bag class, since we can use the result of a call to our private helper method get reference to that we create.
So this is something that we'll see. We'll be reviewing code throughout the course, things in the lecture, the video notes and stuff I'll be reviewing on Thursdays and in Eclipse. And so now we see another use of this private method that we did. This is that same get reference to for another method that we have to implement.
Created earlier. If the helper method returns null, that means that the item we searched for was not in the bag, so we should return false. If the helper method returns a reference to a node, in other words, if get reference to returns a value that is not null, it means that the target item is found in the bag, so our method should return true.
Okay, so that gives us a nice tour of these two approaches for doing a bag implementation. So let me just ask if anybody has an opinion, which does an array implementation or a linked implementation have look better to you for an approach that you might want to be using? It's okay if you don't have an answer for that, but I just want that might be a question that you want to be, by the end of this course, you'll be able to think through and answer. This is the first of several trades that we'll be thinking about. And so we will be able to answer that question for whether we want to do let me go back to my little example here, chart. Now we've talked about array and a linked. We can have an array and a linked implementation of a bag, an array or a linked implementation of a stack, an array or linked implementation of a queue, and it just goes on and on from there. That's the first of one of the trades that we're going to be thinking about. We're going to get into it a little bit later. We can do things in an iterative fashion that's probably easier to conceive, but another trade that's going to come up, there's something called recursion. Has anybody had any experience or heard of recursion? Okay, so maybe you've at least heard about it. Well, we'll get a chance to be thinking about how we do something recursively. So this kind of image here is trying to give us a sense of, so you take a problem, you break it down into a smaller problem, breaking it down into a smaller problem by calling that same method, that same code again and again, referencing to a smaller and smaller value till it gets to an extremely easy decision, you're done, and then you unravel back out for each of those versions of that recursive call that you've done. So I just wanted to have us think about that. So on Thursday, we'll go over a linked data implementation. And to start out with, we'll talk about the efficiency of algorithms, and we'll have a couple of short video notes to give us a sense of that. So how you implement it makes a difference, and it actually at times can make a huge difference. And if you read ahead in the textbook before Thursday, you'll see that. So let me just ask once again, in terms of your project, how's it going with your project? You feel good about what you've chosen, and you can also revise it if there's things that you end up wanting to change a little bit. So that's going to be the first snippet that you'll be doing in terms of submittal, and the next one will be focusing on bags. And so we talked about it on last Thursday. I hope you downloaded those and hopefully you successfully have all gotten that within your Eclipse environment and you're starting to look at that code and comparing that with what we've done in our class. Okay? So I think that's a good breaking point, but I'll pause and see if there's any comments or questions that you guys have.
For the bags,
Mhm.
bags assignment, what exactly should we have to do? Submit?
You're going to, as a minimum, you're going to have 3 pieces of code. You're going to have the .java interface, so the bag interface .java.
Yeah.
You're going to have an implementation of that interface. Remember, I showed you that last Thursday, where you have that interface, and then if you, in the way that when you're creating a new class, you say that implements, and then you get the code stubs and you fill in those code stubs. That would be the second piece of code. And the third piece of code is you have to have the application. This is what refers back to your theme of what you want to be doing with your data. So like the Tour de France, and so maybe this is just a collection of the top 100 writers or top 10 writers. If it's a wedding planning, the first 10 people that submitted that they wanted to go to the wedding. There's no particular order, just to give you an idea. And then we're going to be having different things that we're going to do. The first 5 are baseline. The last 2 are extra credit that you guys are welcome. You can only get more points by trying to do some of these extra credit items, but we'll come back to that later. Does that help?
Would you happen to have an example or maybe an output of what we could do? Or do you not have anything?
That would be what I was showing last Thursday. You remember?
Uh,
Okay. I don't know why it does this. It seems to do it when I'm here in class. It stops sharing my screen, so I'll have to open up Clips again. Share again and then open Eclipse. So there's a couple of things it'll ask for. Remember, at the very end, you're going to be asked for a final report. So the first thing it's going to ask, what is your project? What are you trying to do? That was your project proposal. So if you have it very short there, you're going to have to add a little bit more detail for when you do your final submittal. And then the next thing that's going to ask is, okay, well, what are you trying to do with this first sub-project? That's a paragraph or so that you're going to be putting into this submittal. That's going to be another paragraph that's going to go into your final report. The next thing that you're going to be putting in, and that's probably really small to see. I don't know what happens if I do this.
Is it about project proposal or bag assignment?
I'm trying to mention how they're related.
Oh.
That's the reason why I was giving that context. And so you're only going to have one, but I was just trying to show you in your development. And so, for example, if I did here, I'd have the bag interface. You're not going to have a driver. You're going to have an application, but you're going to have you're going to have an implementation of that bag interface. That would be number 2. And number 3, you're going to have an application. Okay. And so this is just a generic example here. Here is a piggy bank example. There is a little bit of complexity in this that we're going to have a few more. So we have the bag interface. We do an implementation of an array bag. And then we have a piggy bank example. But there's a couple other things that they do. They have the coins. Okay. So you have to have a class for a coin. Then you have the coin name. So if we're going to be doing it in US currency, we could do it for Canadian currency. So this is where that is captured. And then we have this other characteristic that's unique to this thing is, well, we decided to have another class for the piggy bank itself. But as a minimum, you'd have to have the bag interface, the array bag, and the implementation. So that's one of the reasons why I didn't share that one, because that's more complicated. Does that help?
Yeah, would it be possible for you to just look at my code and see if I just need to fix anything.
Yeah, probably a little bit easier for me to do it on Thursdays. But how's it going with your bags project? Maybe I should ask you that.
Well, so I was just using the outline that was included in the zip file.
Uh-huh.
So I don't know, I'm not sure if the output is supposed to be like, you know, how you add it. Let's say, because I'm trying to make a, let's say I'm making a playlist and I would add, let's say, song 1 as a title. And then I would just test and contains. And would I just output each element in the bag? Is that the idea?
Well, let me just open it up and you can see what I mean by the submittal. So for the bags, you can take it as many times as you would like. So the first thing is describe your project. So that's the narrative. Okay, that's going to be for this submittal, but you're also going to be using it for your final project report. There's a question, does your program work or not? Yes or no? So that needs to be included. And plus share your Java code. So you want to have a yes, you want to be including your code as a zip. I also, I can't read a zip in Canvas, so I'm asking you just to copy and paste your code into another question so I can easily review what you've got. So that's,
Java files.
yeah.
Blank space.
And then any other additional files. So you could either include the zip here, or you can include the zip down there. So it should be similar on I think all of you have a Mac, is that right? So, but if it was a PC, it'd be similar. So I'll just go to where I have my Eclipse environment. And so it creates a folder for every project. So what I'm saying is you just compress this and it'll produce a zip file, and then you can just upload that. Okay? Is that clear? All right. Well, I think that's a good breaking